Hello, in this video we will be covering Module 2, Lesson number 6. Ratio, percent, and percent increase and decrease applications. The first little bit of notes here to look at, ratio applications are what we're going to start with. And in number 1, we're given that the ratio of a quarterback's completed passes to attempted passes is 2 to 9. If he attempted 45 passes, find the number of passes he completed. So looking at this in just a couple of steps, what we want to start with is represent what we are trying to find with a variable. In this problem, the unknown is the number of completed passes out of 45 attempts. So we're going to let x equal that, the number of completed passes out of 45 attempts. And we can set up a proportion using the ratio that's given, 2 completed over 9 attempted, and what we're trying to find, x completed over 45 attempted. We solve this by using our cross products. 9 times x equals 2 times 45. 9 times x equals 2 times 45 is 90. Then dividing gives us that x equals 10. Now, one thing to notice here, I should have mentioned this earlier, in our proportion, when we set up those ratios, notice how keeping the units there really makes it easier to see what way to set up your two fractions in the proportion. We have completed over attempted on the left-hand fraction and completed over attempted on the right-hand fraction. Okay, so now the final step in this problem is labeling and stating our answer. So that x equals 10, well, what does that actually mean? That we're looking for, back up at the beginning, the number of completed passes out of 45 attempts. So he completed 10 passes, 10 completed passes. He completed 10 passes. Now we look at number 2. On an architect's blueprint, 1 inch corresponds to 4 feet. If an exterior wall is 30 feet long, find how long the blueprint measurement should be. Write the answer as a mixed number if necessary. So we're given a couple of ratios again. The first one is that 1 inch corresponds to 4 feet. And the second, it says an exterior wall is 30 feet long. Find how long the blueprint measurement should be. So we're going to let x be the blueprint measurement. The blueprint measurement. And that blueprint measurement would be the one that corresponds to 30 feet long. And so then we know that in our other ratio, the 30 feet is going to be opposite the 4 feet in the first ratio, and our unknown, our variable x, is above that 30 feet in the ratio. Now we use cross products. 4 times x equals 1 times 30. 4 times x equals 30. And now dividing, just like we did in the last problem, gives us that x equals, now 30 doesn't divide evenly by 4, but we can simplify that fraction to 15 over 2, or 15 halves. More importantly, the question says specifically to write your answer as a mixed number, if necessary. 15 halves, we can certainly write as a mixed number. That would be 7 and 1/2. 16 divided by 2 is 8. 15 divided by 2 is 7 1/2. Now, what is that 7 1/2? Is it feet? Is it inches? Well, that x is the blueprint measurement, so our answer would be 7 1/2 inches. Now looking at number 3, we're told that there are 3.8 milligrams of iron in a 3.5 ounce serving of beef. Question is, how much iron is in 5 ounces of beef? Round your answer to the nearest tenth. Once again, our units are going to make it much easier to set up this fraction. So we're given 3.8 milligrams of iron over 3.5 ounces of beef. That's the first ratio in our proportion. The second, how much iron is in 5 ounces of beef? So that would be X milligrams in 5 ounces of beef. Using our cross products to solve this equation, 3.5 times X equals 3.8 times 5. Multiplying on the right-hand side gives 19. 3.8 times 5 is 19. And then on the left-hand side, to solve the equation, we divide by our 3.5, giving us an answer when we divide of 5.42857. It's a repeating decimal. Okay, so the question specifically says to round to the nearest tenth. So we're going to round this for our solution to 5.4. And now our units, coming back from the original setup of this problem, milligrams of iron. Now we'll look at some percent applications. Now if you remember previously when we looked at percents in another lecture, we had the formula, the equation, percent over 100 equals part over whole. That's really going to be useful as we set up these percent applications. So in number 4, we're told that one day 78 nurses were out sick with the flu. If this were 52% of the total number of nurses, how many nurses were there altogether? So we start this out, percent over 100. We're given 52% of the nurses were sick. And that 52% was the 78 nurses. So that is the part. So 78 nurses is our part. And we are looking for how many nurses were there altogether. So the total number of nurses. 78 nurses over X nurses. We can use our cross products to solve this equation. 52 times X equals 78 times 100. 78 times 100 is 7,800. And just like in all the other problems, we're going to divide by 52. And that gives us exactly 150 nurses. And that would be the total number of nurses. 78 were sick, 150 total. Now looking at number 5, 40% of the students in a school are male. If there are 465 students altogether, how many students are male? Just in reading that 465 should kind of stand out as the whole. Okay, and we're looking for how many students are male. That would be the part. So setting up our proportion, percent 40 over 100 equals part over whole. That would be X students over 465 students. Again, that 465 is the whole, the part is X. Cross products gives 100 times X equal to 40 times 465. When you multiply 40 and 465, you should get 18,600. So that when we divide by 100, we get exactly 186, and that would be male students for our units. In number 6, in a recent survey of 4,050 people, 81 said that their favorite color of car was blue. What percent of the people surveyed like blue cars? So, we are told that we're looking for the percent because, well, very clearly they say what percent. So that would be x over 100 in our equation for percent over 100 equals, now 4,050 people and 81 said that their favorite color was blue. That 81 would be the part, and 4,050 would be the whole. Once again, we use our cross products. 4,050x times x equals 81 times 100. And 81 times 100 is 8,100. Once again, we divide by that 4,050. And we have that x is equal to, now 8,100 divided by 4,050. 4,050 is exactly half of 8,100. So that x, what we end up with is 2. Now, in all the other problems, we've been keeping track of our units. What are our units in this one? If we're looking for a percent, well, our units are simply that percent symbol. So 2% of the people surveyed liked blue cars. The final topic in this section, we're going to look at percent increase or percent decrease applications. Now, we have a formula for percent increase and decrease applications. We have our percent increase or decrease over 100 is equal to the difference, and that difference is the new value minus the original value divided by the original value. So the difference over the original for the right side of our proportion. In number 7, a union contract calls for a 6.5% salary increase for all employees, and we have to determine the increase for a worker who is currently making $28,390, and we're told that we can round to the nearest cent if necessary. Okay, so setting this up using the formula given to us, percent increase over 100 will take 6.5 over 100, and that is equal to the difference, new value minus original value, over the original value. The only issue here is that we don't know what the new value is. We don't know what the increase is, we don't know what the new value is. So for this problem, what I'm going to do for my variable is I'm going to say let x equal, not the new value or the original value, but I'm going to let x equal the difference. Because that will actually make my proportion look a little bit cleaner, and I don't have to substitute in as much. If I said that x is going to be the new value, then the numerator of my fraction is going to be x minus 28,390. But by calling x the difference in this person's salary, this worker's salary, allows me to set the numerator of my fraction as just x. Okay, the x is going to be the actual dollar amount that his salary is increasing. Okay, so then the denominator of that fraction, the original value, is 28,390. So the setup a little bit more challenging in this one, but the rest of this solution is going to be virtually the same as all the previous problems. We take our cross products, 100 times x equals 6.5 times 28,390. When we multiply 6.5 times 28,390, we get 184,535. And on the other side, 100 times x. Dividing by 100 gives an answer of x equals $1,845.35. Okay, so that's the solution to our proportion, our equation, but that's not actually the answer to the problem. So remember, what we said at the beginning or earlier, was that X is the difference in this person's salary. So if the difference is $1,845.35, what is their actual salary? So this person's salary was $28,390, and it's going up by, it's a percent increase, $1,845.35. So their new salary, if you add those two numbers together, is $30,535.35. Okay, so in this problem, when we solved our proportion, we ended up with the increase in their salary. So we've got to make sure that we add it onto the previous year's salary. In number 8, we're given the number of video stores in a region recently decreased from 125 to 105, and we need to find that percent decrease. So in this one, since we're looking for the percent decrease, that is our x in our equation. So the percent increase or decrease, x over 100, is equal to the difference, and now it says new value minus original value. So what is our difference? The new value, it decreased from 125 to 105. So our new value is 105, and our original value is 125. And then the denominator also, again, the original value is 125. So that subtraction we're going to do first before we take our cross products. So I'm just going to rewrite the left-hand side. X over 100 equals 105 minus 125 is negative 20 over 125. Now we can take our cross products and write this as 125 times x equals negative 20 times 100. Now you may be unsure why there is that negative sign in there. Well, this problem, we're looking for a percent decrease, so that negative is going to be in our problem until we get to the answer, and that negative sign represents a decrease in the price, or in the number of stores. Okay, so we multiply and get negative 2,000, divide by 125, and 2,000 divided by 125 is negative 16%. Okay, so the number of video stores decreased by 16%. So I'm going to rewrite that in words. They decreased by 16%. So I dropped off my negative sign and I wrote the word decrease. Now we get to the final problem in this lesson. Number 9, a company increased the number of its employees from 120 to 200. What was the percent increase in employees? Round to the nearest tenth of a percent. Okay, so we're increasing from 120 to 200, and we're looking for the percent increase. So just like before, our percent increase over 100 equals the difference, and in this case, the difference, it increased from 120 to 200. So my new value is 200 minus the original value is 120 divided by the original value. Rewriting the left-hand side and subtracting on the right, 80 over 120. Now we take our cross products. 120 times x equals 8,000. Finally, dividing by 120 gives us that x is equal to 66.7% when you divide those two numbers, 8,000 by 120. 66.6 repeating, but as it says in the problem, round to the nearest tenth of a percent. So I'm just going to take that and rewrite it. What is that 66.7? So it's an increase of 66.7%. That brings us to the end of Module 2, Lesson number 6. Thank you for listening.